So I will wait for 1 more minute, then we will start. Meanwhile, any issues in the previous lectures? किसी को कोई भी doubt? So I'm starting. Any doubts to anyone in the previous lectures? So in the previous lectures, we have dealt with pressure variation and we saw this was the differential equation. और incompressible fluids में और G जब constant है, so this term became constant and we got P2 minus P1 is equal to minus rho G Z2 minus Z1 or Y2 minus Y1. So that was the case when we had incompressible fluids. Likewise, you can have many formulas depending on what kind of behavior is between pressure and temperature. So please remember, in case of liquids, you don't have any kind of characteristic equation. In case of liquid, you don't have any kind of characteristic equation. But in case of gases, you can have a characteristic equation like this. And depending on whether temperature is a constant, whether rho is a constant, rho is a function, you can have different values of rho here, depending on what relationship you are building. Then you will get a different expression for P. So only point that you need to take care is pressure सिर्फ जो हम rho GH लिखते हैं, ये सिर्फ valid in generally liquids है या particularly incompressible fluids and constant acceleration due to gravity. When these two conditions are fulfilled, we get this pressure value. Otherwise, there will be different expressions, and I will not discuss those expressions here. I will quickly go through only by showing this equation. You can do this back home and find out what are the corresponding expressions in these cases. So this was the case of constant temperature. That is, if temperature is a constant, then how can you proceed? So this expression comes out to be for constant temperature gas. Then you can have similarly for adiabatic conditions. So you can have for adiabatic conditions or in general for any kind of polytropic process. So I will not discuss these. You can do back home. Only thing is how in this expression rho G, how rho you can substitute with different expression. This is the only new thing in this. हाँ जी, किसी को कोई doubt? So now I'm coming to the next topic, that is forces on submerged surfaces and bodies. So this is the topic in which we will be studying forces on submerged, that is completely submerged. This is the first one. Second one is floating bodies. And third one is submerged body boundaries or surfaces. तो हमने तीन तरह की bodies को study करना है. First one is completely submerged. Second is floating. And third one is submerged boundaries or surfaces. तो ये आपको जो picture दिख रही है, let me know which one falls in category number 1, that is completely submerged bodies. हाँ जी.
Second one, sir.
Second, I mark this ship as A. I mark this submarine as B. I mark this sea floor as C. So what is A?
Floating body.
Floating body. So this is floating body. So what are the characteristics of floating body? आपको क्या लग रहा है floating में क्या चीज है? some part is submerged within the fluid and rest is in some other fluid. So this is partially submerged. That is called your floating body. What about this submarine? This is
Fully submerged.
fully submerged. And what about sea? What is sea? This is submerged boundary or surface.
Boundary.
Sea is the sea floor. That is the submerged surface. Are you clear? Hai?
Yes, sir.
Now let me know what are these. We are, as of today, we will be doing this category, that is submerged boundaries or surfaces. So sea is the surface which is submerged, and in today's lecture we will be considering these bodies, that is those are surfaces which are submerged. तो मुझे बात बताइए एक मिनट, क्या शिप में कोई सरफेस है जो सबमर्ज्ड है? Surface. So this part
The
The
bottom.
bottommost.
is the submerged surface. In submarine, submerged surface.
The entire body surface.
So submerged surface and submerged body में फर्क क्या?
So when the entire object is submerged without any surface outside, that is a submerged body. Whereas a submerged surface can be a part of a body which is floating, but still a part of its surface is underneath.
Okay. So if you want to analyze this entire body, this is submerged body. So you want to analyze these glass windows only. So these are what? Submerged surfaces. You want to analyze this surface only. What is this? Submerged surface. So how can you differentiate between submerged body and surface? Critically क्या मतलब हुआ? Submerged body में उसके हर तरफ fluid एक ही तरह का है. Submarine का जो glass है, this is the glass of submarine. What is outside the glass? Water. What is on the other side of the glass?
Air.
There must be air. So those are called submerged surfaces. We are only dealing with submerged surfaces today. और जो आपका tutorial sheet है, that is also relevant to surfaces only. So now try to see why do we need to study those surfaces. So these are examples. First, let's take this example. So this is just like an aquarium. तो एक्वेरियम में फ्लूइड की वजह से किन वॉल्स पे प्रेशर लग रहा होगा? These
Side
walls.
wall.
So why it is critical to study these forces? तभी आप देखेंगे कि ये जॉइंट कितना स्ट्रांग होना चाहिए. Likewise, ये मान लीजिए किसी तरह का पिस्टन सिलेंडर अरेंजमेंट है. So if fluid is there, pressurized fluid is there, so that pressurized fluid will be exerting force on this cylindrical cylinder. So the strength of the cylinder should be having a minimum value so that this does not burst. तो हम इसमें प्रेशर की वजह से कितना फोर्स लग रहा होगा, that is our objective. Likewise, in this case, so this is like a window which is having a hinge here. So if you want to close this, In what direction will the force acting due to fluid? Fluid की वजह से किस डायरेक्शन में फोर्स लग रही होगी इसके लिए?
Upward.
Upward. So it will tend to open this up and you want it to be closed. Likewise, this is for curved surface. So what should be the strength of this? Likewise, you have other systems as well, where you want to find out forces on surfaces.
सही है, submerged surfaces की example है क्या?
ये submerged surfaces की example है. अब इसमें submerged surface कौन सा है इस केस में? एक साइड,
Windows.
ये सारा जो surface है ये submerged ही है. इसकी right hand side, this is also submerged. मान लीजिए अब इसके अंदर I had something like this, say a ball which was at this depth. So this is submerged surface or body? So I am drawing the front view. So I have this, say the aquarium, and the fluid is filled up till this. Now let me know, this body is submerged surface or submerged body?
Submerged body.
Submerged body. Because body is solid, so there is no surface that is exposed to some other fluid. The entire body is exposed to this fluid only. Now practical example is this. This is a dam in which on one side there is water and this is the retaining wall. So what side of this wall is submerged? The left hand side of this wall is submerged. So that is a submerged surface. And we want to find out pressure force on this submerged surface due to this water. यानी क्लियर है? किसी को कोई डाउट? Likewise, these are gates. आप लिक्विड को इधर नहीं जाना देना चाहते तो these are gates. But sometimes you want कि लिक्विड चला जाए तो you will open up these gates. So some kind of force is being applied on these gates. So up till this, these are submerged surfaces. Likewise, in this case, this is the submerged surface. Because on this side there is water and this side there is air. And this is the surface separating these two. So this is a submerged surface. Now what kind of surface is this? So are you able to understand what kind of surface is this? This is a glass tunnel in under the sea. So what surface is submerged? हाँ जी, आपने ग्लास टनल बनानी है तो फोर्सेस कहाँ पे लग रही होंगी?
Sir, the outer surface of the tunnel, the one which is in contact with the sea water.
So this is the force being applied by the water and this is the surface. So this is what kind of surface? Curved or straight? This is curved surface. So this is an example where whatever you study today, you will realize that these are critical to design such kind of tunnels. Any clear है? Now this is a submarine And what do you think? What are the surfaces in this case? So you want to find out, so you want to apply these glass window panes. तो प्रेशर यहाँ पे लग रहा होगा, तो आपको किस तरह का एडहेसिव चाहिए, किस तरह की स्ट्रेंथ चाहिए, बिकॉज इनसाइड द सबमरीन देयर इज एयर, outside there is water, and this surface and all the surfaces are separating these two fluids. So these are submerged surfaces. And clear है? किसी को कोई डाउट? किसी को कोई भी डाउट? And this is what is being dreamt of. So what you are able to see is still it is under construction. So you are having a tennis court inside the ocean. So this is a similar kind of tunnel, and you will have the entire tennis court and the audience stands here. So this is still under construction in Dubai. So this is how these engineers will have to actually find out what are the pressure forces on these structures. So this is the practical utility of this topic. And किसी को कोई doubt? Any doubts to anyone? How about now we are starting with the simplest surface, that is called a flat surface now. So I am now dealing with plane surfaces, and the first case is horizontal flat surface. So what do you think in this container, which is the surface that is horizontal as well as submerged? Say I mark this as A, B, C, D. So which surface is submerged and horizontal? Which surface? This is given the front view of a container containing liquid, which is resting on two supports. My question is, which surface is the horizontal surface that is submerged in the liquid? Hanji.
BC, sir.
BC. So BC is the surface that is the horizontal surface. What about this container? This surface is the
सर AB surface नहीं है सर submerged surface सर.
मैंने horizontal पूछा.
अच्छा ठीक है सर.
Horizontal is BC, vertical is AB and DC. These are vertical surfaces that are submerged. Not DC. I should mark this as, so this is A dash. So this is, or I should say this is A and this is D, because only this portion is submerged. हाँ जी, clear है? किसी को कोई भी doubt? Any doubts to anyone? हाँ जी, किसी को कोई doubt? So in this case, this is the surface. So now I'm analyzing one such surface. Say this is the surface. Hanji, please, no disturbance. So this is the surface that is submerged, and say this is at a distance y from the free surface. So this is the free surface and the horizontal surface is at a distance y from the free surface. तो फ्री सरफेस को अगर आप टॉप व्यू देखेंगे, टॉप व्यू looks somewhat like this. So we have drawn a general surface so that this analysis is valid for any kind of geometry. मान लीजिए मेरे पास टॉप व्यू ऐसे भी हो, टॉप व्यू ऐसे भी हो, टॉप व्यू ऐसे भी हो. This analysis is valid for any general geometry. इन तीनों का फ्रंट व्यू तो मेरे को सिर्फ फ्लैट प्लेट ही दिखेगी इस तरह से. In the top view they will be different. So this analysis is valid for all kind of shapes. So what I am doing is I am finding out the resultant force on this plate. So dF is the force on this small, differentially small element. So this is, we want to find out force on this entire horizontal surface. तो हमने एक छोटा सा एलिमेंट ले लिया and this element is having say area dA. तो इससे प्रेशर फोर्स किस डायरेक्शन में लग रही होगी? Perpendicular to the surface. So please remember, pressure force is always perpendicular to the surface. So please remember this rule, and if you remember this rule, you will never get confused whatsoever is the shape of the surface. So dF is the small force acting on this differentially small element having area dA. I want to find out the force in the total surface. So dF is pressure into dA. Now what is the pressure force at this location? If this is incompressible and G is constant, what can I substitute P with?
Rho gy.
Rho gy. So rho gy into dA becomes dF. And if I take an integral to find out the total force, so this is the resultant force, this becomes rho gy dA, and I know that rho g is a constant, so rho g I can take out of the integral sign. This is y dA. And what is y dA integral equal to? If you remember from your mechanics course, y dA integral upon dA integral was equal to what? Yc, that is a centroid, and dA integral is A. So I get y dA, I can write down this as rho g A yc. Any clear? So resultant force on this plate is rho g A into yc, where yc is the centroid of this plate. Any clear hai? And what will be the value of yc here?
Y.
Y only. So yc, so this is also equal to here rho g ay. किसी को कोई भी डाउट? Any doubts to anyone? And where will be the force acting?
At the center of pressure.
At the center of
Pressure
pressure.
center.
So how can you find out center of pressure?
सर वो परपेंडिकुलर एक्सिस थ्योरम नहीं पैरेलल एक्सिस थ्योरम.
Okay. So I will not do it here. I will do it for a much complicated case. This is a simple case. I will leave it for you. So now I am coming for submerged plane surfaces. Now, but now the case is for a vertical flat plate. हमने पहले किया horizontal के लिए. Now this is for vertical. So you can imagine with this physical example that this is a plane wall which is retaining some fluid. So up till this point, the surface is submerged. So this is the submerged vertical surface. Likewise, you have up till here this surface and this surface. So please remember, in this case, as it was in the previous case, अब मुझे ध्यान से बताइए, यहां पे एक चीज आप भूल गए हैं, यहां पे और क्या आना चाहिए? आना चाहिए कि नहीं आना चाहिए, ये बताइए पहले. यहां पे कितना प्रेशर होगा टोटल?
PATM.
PATM. यहां पे कितना होगा?
ATM plus rho
PATM plus
GH.
rho GH.
PATM plus rho GH. And will there be some pressure from this side? If this
Wall
is
pressure.
atmosphere,
Yes, sir.
ठीक है, तो यहां भी P atmosphere आ रहा है. So that's why we haven't taken P atmosphere in this calculation work. हाँ जी, clear है? This is getting cancelled out. So likewise, in case of these plates also, P atmospheric is acting here as well, and P atmospheric is acting here as well. So again, I need not take this into account because I have equal and opposite pressure force in this direction. So this is sufficient for this analysis. हाँ जी, clear है? किस केस में मुझे लेना पड़ेगा ये P atmospheric? In which case I will have to account for this P atmospheric pressure?
Curved surface.
नहीं, curved surface नहीं है, इसी में I am asking horizontal, this vertical surface.
अच्छा सर, ये अगर वो थोड़ा एंगल पे रहता है सर, इंक्लाइंड.
एंगल पे नहीं, मान लीजिए ये एयर को एक्सपोज नहीं है, and say this is, and you have something vacuum here, or you have another retaining wall here, you don't have anything in between. So pressure force will, atmospheric pressure will not be acting here, and then you will have to consider P atmospheric in terms of P. तो इसका सबसे अच्छा एग्जांपल क्या है? So please remember, if you want to include any kind of force, अगर मान लीजिए ऐसे था, so this is the container, and say some kind of pressurized air is being supplied to this as well. तो यहां तक लिक्विड है, उसके बाद आपने इसमें कुछ P1 और अप्लाई किया हुआ है, और ये हाइट मान लीजिए h है, और यहां पे पड़ी है प्लेट. So what will be the pressure force on this? What will be the pressure force on this?
OGH plus P minus P ATM.
ATM is not there. So
No, yeah, ATM is not.
if ATM
Yes.
is there,
P1.
then this is like this. Then you get P1 plus rho GH minus
Minus P ATM. P ATM.
P18. So that will be then the resultant into area whatsoever. This is the resultant pressure at this location. So please remember that we are doing analysis in which P atmospheric gets cancelled out. So we don't deal in these terms. So this is, so what you are able to see is the pressure force increases with depth. And that's why in all the dams, the retaining wall is somewhat like this. जो यहाँ पे retaining wall होती है, उसकी thickness bottom में हम ज़्यादा रखते हैं, और top पे आते आते उसकी thickness हमें उतनी ज़रूरत नहीं होती. So this is a retaining wall for a dam, because you have high pressures at lower layers, so you require greater thickness of the wall so that this does not break. So that's why retaining walls are made in this fashion. You don't have uniform thickness, but the thickness increases with depth of the retaining wall. हाँ जी, किसी को कोई डाउट? किसी को भी कोई डाउट?
No, sir.
No, sir.
So now I am coming to the analysis of the vertical wall. So like we did for horizontal surface, I am again taking a small differentially small element at a location y. Now what will be the small force dF equal to? P dA. And what is P at this location? Rho g y. So dF is equal to rho g y into dA. If I take the integral, I get the resultant force Fr. This is equal to rho g y dA integral. And again, I know this rho g can be taken out. So I get y dA integral. This is equal to resultant force Fr. And y dA is equal to rho g a yc. So this is the centroid of the immersed part. So please remember, this is yc is the distance of the centroid of this from the free surface. तो मान लीजिए, so this is 5 meters and this is say 3 meters, then what will be the value of yc? What should be the value of yc?
5.5.
Kitna? 5.5.
Yes, sir.
So yc will be 5.5, that is 3 plus 2.5. But the resultant force will not be passing through the centroid. It will be passing through some other point, and that is called center of pressure. So we will find out the coordinates of that point at which this force is acting. So how can you find out that? So using the
By
theorem
Gauss
from
theorem.
statics, that is sum of all moments is equal to the resultant moment into the point at which that is acting. So I'm using this theorem where sum of moments due to differentially small forces is summed up or integral is taken. So you equate this equal to the resultant moment into yp. So what is df into y integral? df was rho g a y into y. This is equal to resultant force. Sorry, this should be force here. Resultant force into the location at which that force is acting, yp. Then Fr into yp becomes equal to rho g comes out of integral sign, and I say I get, this was dA, so I get y square dA. And y square dA integral is called second moment of area. And I represent this with I. And in this case, what should I point out? About which axis is the moment? So this is O dash. So this is essentially I O dash. But I want to make it a more convenient formula. तो मैं parallel axis theorem लगाऊंगा. And that states that if you know moment of inertia about any axis and you want to find out the moment of inertia about the centroidal axis, C dash, you know about O dash, and these axes are parallel to each other, then you know that I O dash should be equal to I C dash, and say this distance is YC, so plus
by
A
c square a.
So you get resultant force Fr into Yp is equal to rho G ICC dash plus AYC square. And Fr is, you already know, Fr is equal to rho G AYC. So rho G AYC into Yp, this is equal to rho G into this term. So finally you get, I'm writing down here. So finally you get Yp is equal to Yc plus, what should I write down? What should I write down? Yc plus, quickly, ICC dash upon AYC. And this term is always positive. So it means Yp will always be greater than Yc in case of submerged surfaces. That is, if Yc
एक सर
was, हाँ जी बताइए
सर एक बुक में सर इन्होंने फॉर्मूले में ना सर एक चीज और ऐड कर रखी है सर इन्होंने सर
क्या?
सर साइन थीटा सर साइन
नहीं,
स्क्वायर थीटा
वो हमने अभी, हम इंक्लाइन के लिए नेक्स्ट में आ रहे हैं, ये देखिए. I have done for horizontal surface, I have done for vertical surface, then I will do for inclined surface. तो inclined में जो आप sin theta कह रहे हो, आप ये वाला केस कह रहे हो ना, ये वाला
sin थीटा फिर दोनों में आ जाएगा ना सर?
हाँ, नहीं तो फिर क्या होगा, बेसिकली sin थीटा में थीटा की क्या वैल्यू है हॉरिजॉन्टल सरफेस के लिए?
सर 1 हो जाएगी सर.
थीटा की वैल्यू 0 है हॉरिजॉन्टल सरफेस के लिए
सर 90 हॉरिजॉन्टल हाँ 0 है सर 0 है.
और वर्टिकल सरफेस के लिए थीटा क्या है?
90.
ठीक है. So that is the more general formula. So I have done it for simpler cases, then I will shift to a more complicated case. But this is not complicated.
इसमें भी सर
हाँ जी.
सर एक बार yp समझा दो. yc प्लस ICC डैश अपॉन AYC कैसे आया?
बेसिकली जैसे हमने पहले में तो कर दिया, दिस वाज, ये तो समझ आ गया आपको FR कैसे आया?
यस सर.
अब आप जैसे एग्जांपल मैं बोलूं, जैसे अगर कोई एक, मान लो यहाँ पे, हाँ ऐसे करता हूँ, मान लो ये एक यहाँ पे पड़ा होता कुछ, तो इस पे बहुत सारी फोर्सेस लग रही हैं, F1 F2. तो अगर मुझे इस पॉइंट के अबाउट मोमेंट लेना है, ए पॉइंट के अबाउट, तो क्या होगा?
F1 into perpendicular distance from here.
तो ये मान लीजिए x1 है एंड से दिस इज x2. ठीक है, तो क्या होगा बेसिकली? F1 into
F1
x1 डायरेक्शन हो जाएगी क्लॉकवाइज, प्लस F2 into x2 डायरेक्शन क्लॉकवाइज.
यस सर.
ठीक है. अगर मान लो इसका मैं रिजल्टेंट ले लूं, इसको इक्विवेलेंटली बना दूं ऐसे कुछ, ये f और ये डिस्टेंस मान लो x पे एक्ट कर रहा है, तो ये क्या होगा? f इंटू एक्स.
यस सर.
तो ये दोनों इसके इक्वल हो जाएंगे, ये दोनों इक्वल हो जाएंगे. ये अगर मैं इसको रिजल्टेंट की तरह लिख के दिखा रहा हूं आप समझ रहे हो कि अगर मेरे पास बहुत मल्टीपल फोर्सेस हैं, उनका मैं मोमेंट लूं और एक बार मैं उसके रिजल्टेंट का मोमेंट लूं, so that is equal.
Yes sir.
So I am applying the same formula here कि मेरे पास df एक फोर्स थी जो एक स्मॉल एलिमेंट पे लग रही थी और वो स्मॉल एलिमेंट किसी y लोकेशन पे था. तो ऐसे ही बहुत सारी फोर्सेस डिफरेंट y लोकेशंस पे लगेंगी.
Yes sir.
तो उनका एक मोमेंट होगा.
Yes, sir.
सबका मिला के वो किसके बराबर होगा? रिजल्टेंट फोर्स इनटू
Into perpendicular. YP.
yp. अब मुझे df पता है क्या है? व्हाट इज df? रो g
Yes, sir.
y da
Yes,
इंटू
sir.
y कर दिया तो ये बेसिकली y स्क्वायर da इंटीग्रल आ गया.
Yes, sir.
And y square dA integral is what? Second moment of area.
Yes, sir.
About which axis? This O dash axis.
Yes, sir.
Okay. So I got moment of inertia about O dash axis, and this is also equal to what? Moment of inertia about the centroidal axis, that is CC
That's
dash,
That's AH square.
plus distance area into distance
This.
square.
Yes, sir.
Are you clear है?
Yes, sir.
अब मुझे इसमें एक क्रिटिकल चीज बताइए. Let me know. This will be CC dash, or this will be CC dash.
Sir, horizontal वाला होगा.
Horizontal वाला. So please take care of this. क्योंकि अगर triangle आ गया, rectangle आ गया, your answer will become wrong अगर आपने ये उठा लिया. This is incorrect. This is the correct one.
Yes, sir.
And you clear है?
Yes, sir.
So this is what you are getting. You are getting yp equal to yc plus some positive term. तो इसका मतलब हुआ अगर ये सेंट्रॉइड था तो रिजल्टेंट फोर्स कहां लग रही है? उससे नीचे लग रही है. So this is the location of resultant force. ये सेंट्रॉइड है yc और ये yp है. This is
Yes, sir.
clear है? So resultant force is not acting at the centroid, but it is acting at a distance little bit lower than the centroid.
Yes, sir.
Clear?
Yes, sir.
So now I am moving to the third case, that is inclined surface.
So we are having class right now.
Okay. So I will continue with this, and one thing more. Man, are you there?
Yes, sir.
So we are actually a little bit behind the other group in terms of coverage, syllabus coverage. So I want if we could keep one extra class, only one, so that we can pick up
All right, sir. I'll find a time and then get you.
and inform me accordingly.
Yes, sir. Definitely.
Okay then. Thank you.